Section 9.6 Bifid. Let's look at one more historical hand cipher based on the 5x5 Polybius square. This is the Bifid cipher, also invented by Félix Marie Delestel in the 1890s. Bifid is a three-step cipher where 1. The letters are converted into their Polybius coordinates, 2. Those coordinates are rearranged, and 3. The coordinates are then converted back into letters. Originally, Delestel wrote out the entire message with the coordinates written vertically under each letter. Then he combined the pairs of coordinates reading horizontally, first across the top row and then across the bottom row. The modern method is to break the message into blocks of a fixed size. The block size should be an odd number, such as 5, 7 or 9. If the block size is an even number, then Emily can separate the blocks into bigrams. The first step is to convert the letters into their coordinates in the Polybius square. Suppose the block length is 5. The 5 plaintext letters can be represented as x1, x2, x3, x4 and x5. Their row and column coordinates can be represented as r1c1, r2c2, r3c3, r4c4 and r5c5. Each of these R and C symbols is a number from 1 to 5, with the row coordinate first and the column coordinate second. These pairs of coordinates are written vertically below each letter in the block, like this. Then they are read out going across the rows in the order R1, R2, R3, R4, R5, C1, C2, C3, C4, C5. Here is an example. The word major is enciphered using a Polybius square that was mixed using the keyword sample. Notice that the third set of letter coordinates in the ciphertext, R5C1, is a row/column pair. This means that the third ciphertext letter will come from the same row, R5, in the Polybius square as the fifth plaintext letter, and from the same column, C1, as the first plaintext letter. This concurrence of both row coordinate and column coordinate is called a natural. Since there are 5 letters in each row and 5 letters in each column in the square, there is a 1 in 5 chance that the third ciphertext letter is the same as the fifth plaintext letter, and a 1 in 5 chance that the third ciphertext letter is the same as the first plaintext letter. That is, there is a 20% chance that R5C1 is the same as R5C5, and a 20% chance that R5C1 is the same as R1C1. In this example, that is exactly what happened. The fifth plaintext letter is R, and the third ciphertext letter is also R. Now look at the first ciphertext letter, R1, R2. This is a row/row pair, not a row/column pair. Here, only the first coordinate, R1, is in the correct place for a row/column pair. The other coordinate, R2, is a row coordinate in the column position. Such a single placement is called a half-natural. It means that the first ciphertext letter comes from the same row in the Polybius square as the first plaintext letter. So there is a 20% chance that the first ciphertext letter is the same as the first plaintext letter. This also happens with the second, fourth and fifth ciphertext letters. Each one of them falls in either the same row or the same column as one of the plaintext letters. Thus, each of them has a 20% chance of being the same as that plaintext letter. This happened in the example, where the second ciphertext letter, J, is the same as the third plaintext letter. This is a serious weakness in the Bifid cipher, which makes it easy for Emily to guess at and place probable words. On the other hand, if the plaintext and ciphertext letters are different, then you know that they are in the same row or column. In the example, the first plaintext letter, R1C1, is M, and the first ciphertext letter R1, R2 is S. This means that M and S must be in the same row of the Polybius square. When Emily deduces or guesses a word, that provides several of these equivalences. This in turn makes it easier to place additional words. When enough of these letter pairs have been accumulated, Emily can reconstruct the square. Due to these weaknesses, the Bifid cipher is rated 3. Section 9.6.1 Conjugated matrix Bifid. These problems can be eliminated by using a different Polybius square to convert the coordinates back to letters. For example, square 2 yields the ciphertext VBJEF. Bifid with two separate Polybius squares is called the highfalutin name conjugated matrix Bifid. In this context, a matrix simply means a rectangular array of letters or characters. The conjugated matrix Bifid cipher is rated 5. There are several ways to boost the strength of a Bifid cipher. One way is to vary the block length using a repeating numeric key such as 5, 11, 7. The block lengths would be a cyclic repetition of this key, namely 5, 11, 7, 5, 11, 7, 5. If you prefer, you can generate the block lengths by using the chained digit generator and translating the digits to odd block length. One possibility is: so if the generator produced digits 3, 6, 2, 7, then the block lengths would be 11, 7, 9, 9. Using a short repeating key and conjugated matrices, the cipher is rated 6. With a long repeating key or generating the block lengths using a random number generator, the cipher is rated 7. A similar idea is to read out the coordinates starting from a different point in each block. You could use a numeric key to specify the sequence of starting points. If the block length is L, each number in the key may be anywhere from 1 to 2L. A number from 1 to L would indicate a starting position on the top row of coordinates, while a number from L plus 1 to 2L would indicate a starting position on the bottom row, like this. The coordinates would be taken out in pairs reading from left to right. Here is the order for reading out the coordinates using the numeric key 4, 9. The starting positions 4 and 9 are shaded. This method increases the rating to 6. Another way to strengthen the Bifid cipher is to use a stronger transposition to mix the coordinates. The standard Bifid using a block of length L takes the 2L coordinates and writes them into a 2 times L block. The coordinates are written into the block vertically and read out horizontally. We recognize this as a very simple root transposition, described in section 7.1. There are several stronger transpositions covered in chapter 7, notably columnar transposition. One example of this type of cipher is the ADF-GVX cipher, invented by intelligence officer Lieutenant Fritz Nebel and used by the Germans in World War I. In the ADF-GVX cipher, the coordinates, represented by the letters A, D, F, G, V, X, are mixed using the columnar transposition and then transmitted as a string of those letters. This cipher is rated 5. If you used longer blocks, say 20 characters, that would give you 40 coordinates. With this method, the block lengths may be either even or odd. This is enough to use columnar transposition effectively to mix the coordinates. Or you could go back to de Lastelle's original concept and take the coordinates for the entire message as a single block. Either way, using conjugated matrices, this cipher is rated 8. Using a double columnar transposition, the cipher is rated 10. Assuming 4 long independent keys and well-mixed alphabets, this is an unbreakable paper and pencil cipher. Call it double columnar Bifid.